Today we're going to be looking at graphing logarithms, and one of the important things to remember about logarithms is that logs are inverses of exponentials. In other words, their x and y values switch, and that's going to help us graph this today. So let's take a look at the log base b of x, where the base is down here. Now, if I want to graph this, if I look in terms of an exponent, I had a parent point and an extra point. The idea is the same. In an exponential, the parent point was 1 followed by the base, and the extra point was always 0, 1. Well, in logs, because they're inverses, we just switch the x and y values. We get the base 1, and the extra point becomes 1, 0. And we can, of course, graph it. So I get the point, the base. Now, I don't know what the base is, so we'll go like maybe, we'll call it 2 for now. The 2, 1, 2, up 1. There's our parent point, and 1, 0, our extra point. Let's talk about now about the asymptotes. Now, in an exponential, we have the horizontal asymptote, y equals 0. Well, a logarithm, we switch it, the y becomes x. We get x equals 0, and therefore we get our vertical asymptote at x equals 0. And just like before, we're attracted to asymptotes, so it's heading towards the asymptote, and on the other side it goes away. Don't ever draw it towards again. That won't be a function. And this is what our logarithm looks like. So the vertical asymptote of the basics will just be x equals 0. The range this time is all real. See, we just switched them around. Remember, the domain was all real yesterday for exponentials. The domain is going to be from 0 to infinity, just like the range yesterday was 0 to infinity. Natural log of x works the same way, except for our parent point, it's going to have the base e1. And the extra point, as always, will be 1, 0. And we do have a vertical asymptote, x equals 0. So if I want to sketch this, very easy to do. 1, 2, 3. Remember, e is a little bit between there. Up 1. Whoop, missed it. And 0, 1. There's my vertical. And I can get my graph of my exponential function, my natural log function. Again, it's domain 0 to infinity. Range negative infinity to infinity. Easy breezy. So let's go ahead and look at the general equation right here. Okay? The domain and range, I never worry about those. These come from the graph. The vertical asymptote, it's vertical, so it's going to be x equals, now yesterday it was y equals k, because think about it, that's my y, that's my horizontal shift. Well, we want a vertical, so it's going to be x equals h to get my horizontal. The parent point is going to be the base 1. And the extra point, it's going to be 1, 0. And this is always, right? And that never changes. Again, the domain and range, even if it's a natural log, we get the domain and range from the graph. The vertical asymptote, still x equals h. The parent point, except for it's going to be 1e because we know it's natural log. Natural log's base is e. The extra point, 1, 0. And let's take a look at a couple of examples on graphing these. All right. Number 1. So if I want to graph this, first I get my transformations, list out the b hack, how I transform. There is no b because I'm not multiplying anything by k, by the x. There is an h, negative 1, so it's negative 1. Remember yesterday that meant to go, it becomes positive because it's on the inside, and that's telling us to go right 1 unit. There is no a because I'm not multiplying anything here, but there's a k plus 2, and that says to go up 2. My parent point, remember it's the base, comma 1. So it's base, there's my base, tag, you're at, just kidding, there's my base, it's 2, 1. My extra point, always 1, 0. And where I get the extra point from is from yesterday. Remember, the extra point yesterday was 0, 1 for exponentials. Because it's a log, I flip it. Okay? My vertical asymptote, x equals h, so x equals 1. And we'll get all this stuff from the graph in just a few moments, hopefully. If I were to sketch this, my parent point 1, 2, up 1, and my extra point 0, 1, 0, sorry. And I graph my vertical asymptote, x equals 1. Shifted. Sound effects always are kind of nice. And now I translate it. Every point goes right 1, up 2, 1, 2. Take my parent point, right 1, up 2, and there we go. And there's my parent point. And remember, we're going to go towards the asymptote, directional. Don't go up like, whoa, it doesn't do that. It goes, it's monodirectional. So it's going to go down, and on the other side, it actually breaks away. Be careful, these aren't rational functions, so we're not going to go back towards the asymptote. Now, look at the graph here. Does this have an x-intercept? Yes. Let y equals 0. Solve it. 0 equals log base 2 of x minus 1 plus 2. Solve it. We get negative 2 equals log base 2 of x minus 1. Now, we haven't reviewed how to solve logarithms yet, so we'll talk about that later on. But if you might remember, we're going to take this base 2, raise it to the negative 2, and we set that equal to the x minus 1. So therefore, x equals 1 over 4. Remember, 2 to the negative 2 is 1 over 4 plus 1. There's your x-intercept. Now, there is no y-intercept. Does not exist. Doesn't cross. But I'd like to see why. Let's take a look. Y equals, let x equal 0. The log base 2, 0 minus 1 plus 2. Y equals log base 2 of negative 1 plus 2. Now, we can look at it graphically and say there's no solution. But why does our equation tell us no solution? That's because of this. Logs can't be negative. You can't take the logarithm of a negative number. We'll talk more about that in a couple of days, okay? It has to deal with what we call the inverse property of logs. So there's our answer right here. Our domain goes from 1 to infinity, and our range, negative infinity to infinity. And there we go. The x-intercept you might want to practice one more time at least. All right, so let's take a look at number 3 now. All right, now number 3 has a whole bunch of transformations. This one goes crazy. B-hack. There is no B, but there is an H. It's negative 3, so we're going to go left this time. There is an A, it's a negative 2. So basically you can take every y value, multiply every y value by negative 2. It's a vertical reflection and a stretch. There is a K, it's negative 4. That means we're going to go down 4. We go down 4. Our parent point, remember it's the base, 2, 1. And our extra point, always 1, 0. Vertical asymptote, there's my H. It's x equals negative 3. Very good. We have to change our sign, because remember it's x minus h, so we have to change our signs. And the rest we'll get from the equation, the graph, if we can. So let's go ahead and graph this one here. Graph your parent point, 1, 2, up 1, 1, 0. My vertical asymptote, left 3, 1, 2, 3. There's my vertical asymptote. And I just transform it. Ready? Give a few more points here because we know we're going to have to do some multiplication. All right. Everything goes left 3. 1, 2, 3. Multiply it by negative 2. My y value to stay 0 and then goes down 4. 1, 2, 3, 4. Left 3. 1, 2, 3. Multiply by negative 2. 1 times negative 2 is negative 2. Down 4. 1, 2, 3, 4. There's my new parent point. So how is this going to look? What's going to happen to it? Well, start at your parent point. Head towards your point. I'm heading towards the asymptote. So this time we're going to go up towards the asymptote. And on the other side, it breaks away. So there's our graph right there. Now this has an x and a y-intercept, so let's go get the x-intercept by letting y equal 0. We get 0 equals negative 2 log base 2 of x plus 3 minus 4. So if I isolate this, bring over the 4 divided by negative 2, we get negative 2 equals log base 2 of x plus 3. 2 to the negative 2 equals x plus 3. So x equals 1/4 minus 3. Check this again. It's been a while since you've done this, okay? We're going to talk more about this in a few days. But right now, just check those. To get the y-intercept, let x equal 0. That's easy enough. Y equals negative 2. Log base 2 of 0 plus 3 minus 4. We will have a y-intercept this time. It will cross it. We get negative 2 log base 2 of 3 minus 4. I don't know what that is, so we just leave it, okay? Our domain, negative 3 to infinity. Soft bracket because it's an asymptote. Our range, negative infinity to positive infinity. Very easy to do. So you may want to try this one more time. What's going to be hard are the x-intercepts, okay? All right, so go to part 2. We'll take a look at a couple more examples with you, okay?